Alright, Kara, so today we're looking at the periodic table. Another really important part of your syllabus. So in your periodic table it should look similar to this, but for you only need to concentrate on this. From here, this section, and this section. Yeah. As you can see, if we look at the trends on the thing in the periodic table, from here to here you have your metals, and from here to here you have your non-metals. Okay, this is going to be useful in terms of, bonding, ionic bonding, and covalent bonding. But we'll move on to the type table. So as you can see, I've already drawn out one of the things you're going to need. So when you look at your periodic table, there's a couple of things you need to know about it. Okay, you have numbers at the top. Okay, 1, 2. So let's go back to this. So you have 1, 2. These are fine, but the numbers you need to worry about are these numbers here. So 1, 2. This little bit here are called the transition metals. You don't need to worry about that for your syllabus. You need to worry about 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we're looking at these numbers here. That's it. That's 1, 2, 3, 4, 5, 6, 7, 8. These numbers are called group numbers. Okay. So they run down here. 1, 2, 3, 4, 5, 6, 7, 8. The numbers on the side, these numbers are called period numbers. They tell you the periods. Alright? And they form rows across here. That's right. Alright, so let's just go through. The group number tells you the number of electrons that the element has, Let's take it for example. So these are the group numbers. So if I go down, say on lithium, it tells me all the atoms, all the elements and atoms down here, they all have 1 electron. Sorry. The group number tells you the number of electrons in the shell. So do you remember from the previous video we drew this 2, and you have the electrons on the outside in your shells? This number tells you how many electrons are in the so the outermost shell of the atom. So if we look at hydrogen, this says apparently this number, this number here is telling you that all the elements in this column all have 1 electron on their outer shell. Okay? So what does this mean? So let's put this to the test. So you have hydrogen, lithium, sodium, and potassium. So let's look at sodium, yeah? Let's see if this is true. So sodium has got 11. This is the proton or electron or atomic number. So it tells me it's got 11 electrons. So we're going to draw our atom electron structure. So that's the nucleus. First string has 2 electrons in it. Second ring, the maximum you can go up to is 8. So remember, its sequence is 2, 8, 8. That's the ring capacity. Okay, so the second one, we've done the first one, now we're going to the second one. 2, 4, 6, 8. 8 plus 2 equals 10. But there's 11. So we need to put another ring on. That's 11. And then what you know, there's only 1 electron on the outer shell. That's why sodium is in group 1, because it has 1 electron in its outer shell. And that'll be the same for potassium. So should we look at potassium? Alright. So potassium, atomic number is 19. Let's look at this again. 2, that's 10, so 8, 9, 10. And this is 19. So 10, so 2 plus 8 is 10. 10 plus 8 is 18. But this has got 19 in it, so we're going to draw another shell to put that electron on. So how many electrons on the outer shell? Only 1. That's why potassium is in group 1, because it has 1 electron. 1 electron on its outer shell. Okay? You do this for all the rest of them, Kari, yeah? So group 2, that tells us that this has 2 electrons. All the elements, all the atoms on this only have 2 electrons on the outer shell. So let's look at magnesium, for instance. Let's just get this out of the way. Magnesium, for instance. So magnesium has 12. That's its atomic number, or proton number again. Let's look at it again. 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's put 2 more on there. 1, 2. This is 1, 2. 2 electrons. And what group is it in? Yeah, that's right, it's in group 2. Yes? So all the elements in this group, column, have 2 electrons in the outer shell. And it's the same for all the rest of here. This group here is 8. So that tells us there's 8 electrons or in its outer shell, except helium. This one has got 7, 6, 5, 4, 3, 2, 1. So the group number tells you the number of electrons that the element has on the outer shell. Okay. The period number, i.e. the columns going here, tell us the number of shells or orbitals. So it's saying sodium has only got 3. Has only got 3 shells. Let's look at that. So this is sodium. So that's 1 shell. That's 2 shells, and that's 3 shells. So that's right. And it's saying potassium has only got 4 shells. Let's count that. 1, 2, 3, 4. So that's right. Why is it really important to know the group numbers and the period numbers? I'll tell you why it's really important, Cara, because the number of electrons an atom has in its shell and the number of shells it has affects its properties. So you'll get to learn this later on, but the fact that all these have complete shells and all these have 1 or 2 shells which are on the outside, they make a massive difference in terms of how they all react with each other. Yeah, this is fundamental in chemistry. All right. Now, what I want to, when we want to, is what we call the octet rule. So I don't know if you heard the octet rule. Hopefully you should have. But in almost all atomic behavior, atoms behavior, with all the electrons, all the end game, what all the atoms want to be doing is they want to get 8 electrons. They want to have what's called a full shell. That's a full shell, and this is a full shell. So all the shell, as I said, this shell can only take 8 electrons. And what I'm trying to say is that all the atoms in the periodic table, all these atoms, they want 8. They want 8. That's the magic number. Yeah, they want to fill up their shell. Really important. Now, the reason why this is really important is that, do you know when I said about all the atoms in this column have 1 electron in the outward shell? These have 2, these have 3, these have 5, 6, 7, 8. Well, the reason why that's important, because, say for example, if we think about this octet rule that they all want 8 electrons, how is, say, sodium going to get 8 electrons? Yeah, to get 8 electrons, to get a full shell, it needs to get rid of an electron, because as we've seen before with sodium, if it gets rid of this, manage to get rid of this, what's it left with? It'll be left with that, and that is a full shell. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 electrons. Then it becomes happy. So basically, all atoms want to become happy. They want to have a full shell of 8 electrons. Okay, so you've got to think about the periodic in terms of the behavior of what all the atoms want to do. So all the elements, atoms of the elements in this column, they all want to lose 1 electron. Yeah. All the elements in this thing all want to lose 2 electrons, because if they lose 2 electrons, yeah, they will have a full shell. They'll be happy. Okay, so these ones lose, all the elements in this one want to lose 2 electrons. Okay, now this is when it gets a little bit difficult, because like when you come to here, this tells us that all the elements in here have 3 electrons on the outer shell. So these can do 2 different things. These can either lose 3 or gain 3. Yeah? Same with this. So no, so lose 3, lose 3 or gain 5. I mean, it's a lot easier for it to lose 3. Okay? So you might go look at this as well. So all the elements here either want to gain 4 electrons or lose 4 electrons. Same with here. They want to either gain. They will want to gain 3 electrons. They will want to gain 2 electrons. These will only gain 1. So you've got to look at this in terms of energy as well. It's a lot easier for the atoms in this row, in this column, and in this column to become happier in many ways, because these guys only need to have 1 electron to become 8, and these guys only need to lose 1 to become 8. If you go in the middle, if you go a little bit closer in, these, it gets a bit more difficult. It requires more energy. These guys need to lose 2 electrons, and these guys need to gain 2 electrons. Now when you go down to 5, 4, 3, because they either need to lose more or less electrons, it requires requires more energy. So they become less reactive. But because it's very because these elements here only required, to lose or gain an electron, these elements here are very reactive. Yeah, because it doesn't take a lot. Because it doesn't take a lot of energy for them to lose the electron. On the same token, though, it's the reason why when you put sodium, anything with sodium and anything with chlorine in, why it becomes sodium chloride, because this thing is looking for an extra electron and this thing is trying to lose one, so they're a perfect match in heaven. Same with potassium chloride. So all the elements in here in group 1 and all the elements in group 7, they're perfect for each other because they're trying to gain an electron and these guys are trying to look for an electron. So that's why they're really highly reactive. They work really, really well. To a certain extent, the same with group 2. With anything in group 6 as well, they'll react really well because they're trying to lose 2 electrons and these boys are trying to gain 2 electrons. Okay, so hopefully you're getting a sense of the periodic table and what it's trying to tell you. Okay, these guys in here, they're called the noble gases. They already have a full shell. They're already happy. So these are very, very unreactive. 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 They're already full. They don't want any more electrons or lose any electrons. They're very, very stable. But all these ones in the middle here, they all react, but depending on how much energy, whatever there is about. Okay? Alright. So, yeah, we've gone through the octet rule. So, we'll just go through a quick example of the octet rule in practice, in motion. So, I mean, this video car is mainly to go through the basics of the periodic table, what the group numbers are, what the period numbers are, and what they tell you about the atoms. But we're just going to go through how the octet rule works in particular. So, say for example, you had sodium and chlorine. Yeah. So we'll draw sodium. So sodium's in group 1. (11 electrons). And this is in group 1. And chlorine is in group 7. So let's go back to chlorine. So sodium is trying to lose this electron so it can be happy. Remember the octet rule, 8 electrons. Now chlorine is in group 7. Let's draw this. It's got 17 electrons. 1, 2, 2, 4, 6, 8. So that's 10. So 7 more. 1. And this chlorine is trying to gain 1 electron to be happy. Okay. Alright, so what happens is if you put them together, because there's such a big need from chlorine to get this, what you tend to happen is this transfers into this, and so the sodium loses the electron and the chlorine gains an electron, and they both become happy. So it looks like this. Let me just do all this. So this is the electron in question. I'll bracket this. And then we have the chlorine, which is 17. 1, 2. Sorry, it takes a bit of time to draw this. 10, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Alright, so as I said before, sodium wants to lose an electron and chlorine wants to get an electron to be happy. Remember? To satisfy the octet rule. Okay? So what happens is, I mean, it's a little bit more complicated than this. There has to be enough electronegativity, negative attraction in the chlorine to attract the electron. So, yeah. An electron has sort of affinity to attract the electron, but you don't need to know that. So what happens is this transfers over to this. And what you're left with is this. See, it only has 1, 2 shells now, 1, 2, instead of 3, because it's got rid of the electron. And now with the chlorine, because it's gained the electron, one, two, three. It's full. Okay? So now you can see all their shells are full. They're both happy. They both fulfill the happy rule. Now, I have to tell you this anyway, just to make things, just to fully explain things to you. Now, but because this has got the extra electron, this now has an overall negative charge. Because remember, from your an electron is negative, and a proton is positive. So if chlorine has gained an electron, its overall charge is negative. If sodium has lost an electron, its overall charge is now positive. And so let's think of a battery. So the overall positive charge on the sodium and the overall negative charge on the chlorine creates what's called an electrostatic attraction, also known as an ionic bond. So in essence, an ionic bond equals the transfer of an electron from one atom to another, so in the sodium chloride. Alright, and it's usually between a metal, remember, remember, these are metals, between metal and a non-metal. These are non-metals. Okay, that's why an ionic bond usually happens between a metal and a non-metal, because the metal is trying to lose an electron, and the non-metal wants to gain an electron. Okay. All right. So I hope that's explained some basics for you, and yeah, thank you very much.